Let's move on. 6.1.2. How would the catalyst affect this reaction? Now, if you go back to the question, it says the decomposition of hydrogen peroxide in the presence of a catalyst at standard pressure and room temperature. Now, you must remember, whenever you are dealing with the reaction of a substance in the presence of a catalyst, and you are drawing to demonstrate the effect of a catalyst on the potential energy time. So let's say this was PE, potential energy time. Remember, if you are given whether it's exo or it's endothermic, let's say I was just drawing this reaction of that. Now, what the catalyst will do, the catalyst will still start at the same, but this reaction will be like this. So the catalyst, what it does, it lowers the activation energy. So you see, that's what it does. This is EA. So this is EA when there is no catalyst, and this is EA with what? With catalyst. So now what does it do? It just lowers the activation energy. By doing that, it speeds up the reaction. So the question here is, how will the catalyst affect the reaction? Number one, it will what? It will speed up a reaction by lowering, by speeding up is already affecting, by lowering the activation energy. The EA, I'll just say EA, the activation energy. Please, you write in full. So it speeds up the reaction by lowering the activation energy. And then the next question, it says use the information on the graph to calculate the mass of hydrogen peroxide that decomposed. So we are here. They said use the reaction to calculate the mass. They gave us a few things here. Number one, Vm. They wouldn't give you this information if it was not important. Now let's go to the formulas that connect Vm. If you come to your formulas quickly, you can see there is our Vm to say N, which is number of moles, is V over A Vm. So if you take that formula in here and write it to say N, number of moles, write that number of moles is volume over molar volume, Vm. Are you getting that? And they gave us a few things here. So we have the actual volume of oxygen. So remember this. What are we measuring? They measured the volume of oxygen produced. But the volume of oxygen produced, and then the question here is asking about what? Use the information to calculate the mass of hydrogen. So by measuring this volume of oxygen, it will lead you back to what was used. Here, you've got the volume of oxygen, you still go back. But how do we do that? Let's find the moles of oxygen. Number of moles of oxygen that were produced. Number of moles of oxygen. So N of oxygen is equal to the volume. Now look at the volume. They told us that in the end they produced how much of the volume? 600, but this what? Cubic centimeter. So V here, V of oxygen is equal to 600 cubic centimeter. But look at the Vm, look at the units in dm cubed. So what you do, you divide that by 1000 to convert it to dm cubed, which is equal to, do that, it will give you 0.6 dm cubed. Very important, convert the units. Whenever you're dealing with cubic centimeters, convert them to dm cubed. Now you can apply now to say number of moles of that is, this is your V of oxygen here. So it is 0.6 over molar volume, which is the molar gas volume, which is 20, they say use 24.45. So that's what you use here, 24.45. And then that is N of oxygen, which is equal to, and the calculator can quickly assist in this case. So it will be 0.6 over 24.45. all right, so what we have, we've got if I can write as much decimals here, it will be 0.0245, 0.0245 what? Moles These are the moles of what, guys? These are the moles of oxygen, remember. But we are not looking at the moles of oxygen. We have the moles. If you still remember, we balanced this equation for the oxygen. It was 2 and 2. If I can write that equation down here to say we have the equation of that, it was 2H2O2. It gave us 2H2O plus oxygen. Don't worry with the aqueous, the liquid and everything, but I just want to check that. Yeah, so this is what we had in the previous question. That's why they say balance it. So whenever you are dealing with calculations, always change everything to moles, and then from moles you focus on ratios, because that's where you can find the mess. So we are saying in the reaction, compare that with that. Look at the ratio. We are saying for every 2H2O2, you need 1 O2. You see the ratio, which is 2:1, the oxygen and the peroxide. So we know the moles. For every 2 mole of H2O2, we get 1 mole of oxygen according to the equation. There is a 1 there. I think that. So 2:1. So that ratio is very important, because you ask yourself, what about 0,025 moles of oxygen? So you write it here now to say, what about 0,0245? Because that's what we just calculated. And then you're saying this is actually, let me do this. This is where you put your x. And then you cross multiply to say that multiplies and this multiplies. See? So you've got that multiplying that and this multiplying that. So after this, what you do, you come here to say, you can see x times 1, which is in here, x is equal to 2 times 0,0245. So what is our x here? And then you have to use the calculator there to say 2 times 0,0245, and then it gives us 0,049, 049. So in here, this is moles, but remember, what are these? These are the moles, because we want it, in this case, x. So it's the moles of that, moles of hydrogen peroxide. So we are going to say moles of H2O2 is equal to 0,049 moles. Alright, so now we got the moles of hydrogen peroxide. Now when you've got the moles of hydrogen peroxide, you have to link back to say, remember, moles is what links you back to the mass. So if you've got the moles, you've got to go to the formula again. Let's go to the formulas, and then we are here now, whereby the moles and the mass, N m over m, you take that formula here to say, but N is equal to m over big M. That's where the part is now. We already know our moles. We can convert it to the mass, but first of all we need that, which is the molar mass of what? Of hydrogen peroxide. And from the periodic table, you know that atomic mass of hydrogen is 1, the atomic mass of oxygen is 16. If I can just come back to the periodic table here, there it is, the atomic mass of hydrogen and the atomic mass of oxygen. That's what you are talking about there. So if you come back here to say, what we have for hydrogen is 1 times 2, because there are 2 of them, and for oxygen it's plus 16 times 2. This is the atomic mass, which is 2 plus 32, which is 34 grams per mole. This is the atomic mass. That's what we're going to use now for the M there, to say N, which is 0,049, is equal to the small m over 34. Now how do we solve the 34 here? You have to then multiply by 34, multiply by 34. Are you with me? So that you can now find m to say m is equal to, and you are now looking at 34 times 0,049, which is 1,666, which is 1,67 to 2 decimal place. Now it's grams. I think the answer, they said leave your answer to 2 decimal places. We didn't check, but I think it's that. So that is the mass, 1,67 grams, and the question was you need to use the information on the graph to calculate the mass of hydrogen peroxide that decomposed. Alright, so that was that part. Okay, next one here, we are looking at this to say, if I look at this, they're saying here, in an experiment, Elena adds 500 cubic centimeter of hydrochloric acid, HCl, with a concentration of that to 1,2 grams of magnesium in a test tube. She records the graph in the mass of magnesium. She records the change in the mass of magnesium as the reaction proceeds at regular intervals. The balanced chemical equation for the reaction is this. First of all, one thing we know is that it is balanced. We don't have to worry about that. So they give us that. The change in the mass of magnesium during the reaction is shown on the graph below, and then they show us that, you see, it started from what? Magnesium started from 1,2, and then it went all the way to the end. It reached completion. The time is in minutes. So in 3 minutes, there was no more magnesium. And then let me read again. In an experiment, Elena adds 500 cubic centimeters. This is the information we have. 500 cubic centimeters. Remember, you're dealing with dm cubed. Convert it. So it's 500 divided by 1,000. Always remember. So this is 0,5 dm cubed. Such things are very important. And then with a concentration of 0,36 moles per dm cubed, its right units to 1,2 grams of magnesium is the correct units. It's in grams in a test tube. So what we have, let's look at the questions now. Identify the limiting reagent for this reaction. So here they were dealing about limiting reagents. Give a reason for the answer. Now look at the magnesium. It started from 1,2, it ended up being 0. So a limiting reagent is the reagent that gets finished in a reaction, the one that gets finished. So you can see that it was magnesium. In the beginning it was 1,2 grams. Then at the end, magnesium, it became 0 grams. So you see that is the one that is actually limiting the reaction. So the limiting reagent is magnesium. And then they ask you for the reason. You say because it finished, or it changed. I just don't want to break the English here. It changed from 1,2 grams to 0. Or you can say because it got used up. Another thing. That's it. It got used up. The limiting reagent is the one that gets finished. It got finished, whatever they'll say, but it changed from 1,2 to 0. If your English is also terrible like mine, just say the magnesium, use the words change from 1,2 to 0. The key word that they want you to notice that it went to 0. Now 6.2.2, calculate the number of moles of unreacted hydrochloric acid. Remember, it is the excess here in the test tube after 3 minutes. Unreacted. Let's do a few things here. Let's follow up this reaction. What are we given? We are given magnesium plus hydrochloric acid. Let me write here magnesium. I won't write the part of the aqueous and stuff like that, but it is that, which is magnesium chloride plus what? Magnesium chloride plus hydrogen as a gas. So forget about, I know you'll say, but you need to write the aqueous, the gas. I know this is just for the sake of calculations. So let's look at if I did balance it, it's 2, everything is 1. This is correct. So now look at this. They told us some information, and they told us the information of what? Hydrochloric acid. Number 1, the volume Elena adds 500. So we've got 0.5 dm cubed. Let's focus on this guy. This guy, we've got 0.5 dm cubed. And then do we have the concentration of this guy? Yes, we have the concentration 0.36. So we have got V of this guy, we have got the C of this guy, which is 0.36 mole per dm cubed. This is for this guy. So far, so good. Now the question is, when you're given V and C, go to the formulas. You'll see something here on the formulas. You can use now this formula. C is N over V. Alright, so let's use that formula here to say we're given C is equal to, let me do this. C is equal to N over V, meaning we can find now N, the number of moles. Always work towards the number of moles. So how do we go about? So if I say C is N over V, my C is 0.36 is equal to N, the one I want, over V, which is 0.5. Right, so when I want to find N now, multiply it by 0.5 on this side, by 0.5 on that side. This is now the maths part, so you can get your N. What is the number of moles? Number of moles of what? Of hydrochloric acid. Don't forget, you need to know which moles, so you need not to confuse yourself. 0.5 times 0.36, which is equal to what? Which is 0.18. 0.18 moles. So these were the moles at the beginning. Now let me mark this at start. So the beginning, from what we are given, this is what you have at the beginning. Then they tell you something to say that they were measuring the change in mass of what? Of magnesium during the reaction. So whatever magnesium used is whatever the hydrochloric acid was used. So let's find the moles of magnesium, because they gave us this. Magnesium changed from 1.2 grams, that's what they started with. So if we say now the focus is this guy, magnesium. Here, magnesium. We know magnesium is 1.2 grams. Okay, now we have the formula for magnesium. Come back here for magnesium to say N is M over M. So we can even find the moles of magnesium to say N is equal to small m over big M. This is for what? This is for magnesium. Alright, so now if I go to the periodic table and find the big M for magnesium, magnesium is where magnesium is here. It's 24. You see, the relative atomic mass of magnesium is 24. I need that because I want to put it here to say number of moles of magnesium, N is equal to M, which is 1.2 over 24. It will find me number of moles of Mg. This is the number of moles, don't forget, of magnesium. So it is what? 1.2 over 24. What do I get? I get 0.05. 0.05 moles. Now what do we have here? I have the moles of magnesium. I have the moles of this hydrochloric acid. Now you need to now make sense out of this. You look at the reaction, you ask yourself, what is the ratio of the reaction of magnesium and hydrochloric acid? Look at this. We have got 1 there. So the ratio is 1 magnesium, 1 mole of magnesium reacts with what? With 2 moles of HCl. Do you see that? So the ratio is what? The ratio, let's go up again. The ratio is 1:2. But now in the reaction, this is our limiting reagent, magnesium. We know that 0.05 moles were used. So if I say to you, what about the 0.05? We focus on the limiting reagent. Then you say it's X. I told you what to do. You cross multiply. This multiplies that, and this multiplies that. What are you trying to find? You're trying to find the number of moles of HCl. So you can see that you're multiplying by what? By 2. So you're saying X here 1 times x is equal to 2 times 0,5, which is 0,1. So moles. If you multiply 0,05 times this, you get 0,1. Let's just cross check that. If ever I might be missing 0,05 times 2 is what? 0,1. So I can come back here and say therefore moles of what? HCl used, we just found them, which is equal to 0,1 moles. I think that. Now the question was what? You need to what? They said calculate the number of moles of unreacted HCl. There we go now. So what was used? This was used, but what started? I showed you in the beginning. It started. They had 0,18. Now used 0,1. So unused, you can then conclude to say therefore unused moles of HCl, you subtract, which is 0,18 minus 0,1. Then you subtract that, it will give you then the unused 0,18 minus 0,1, and then there we go, it's 0,08 moles. Then that's the answer. They didn't say mass. If they wanted mass, you can convert even this to mass, but let's end it up here. So that is what they actually wanted to find. Guys, it's, yeah, how many marks? You get 19 marks. Is it bad? Not really, but that is what they needed. All right.